Systems of linear equations in three variables. Systems of equations in three variables are very similar to systems of equations in two variables. There is just one additional variable and one additional equation. So if you look at the example here, we have three equations and we also have three variables. So a lot of times we call this a 3 by 3 system. Also, notice that each of the variables is raised to the first power, which means that it is a linear system of equations. Now, how do we solve them? Well, solving these can be a bit more difficult than a two-variable system because there's just more work and more things to keep track of. The primary method for solving a three-variable system is going to be the addition method. Now, notice that I have numbered the equations here, right? So the first equation has the number 1 next to it. That's this equation. The second equation has the number 2 next to it. And the third equation has the number 3 next to it. That's just to help us talk about this system without having to read the equation every time we want to refer to one of the equations. So look at equation 1 and equation 2. What I want you to notice here is that one of them has a positive y and one of them has a negative y. So if we add those two equations together, the y's are going to cancel out. So let's go ahead and do that arithmetic. If we add, again, equation 1 and equation 2 together, the positive y and negative y cancel. X plus 2x is 3x. Z plus z is 2z. And 6 plus 3 is 9. And then we will save this equation. So now what do we need to do? Well, whatever we do, we have to involve the third equation. And what I want to do is eliminate the same variable. So if I eliminated the y variable the first time, I want to eliminate this y variable right here. Now, the easiest way to do that, since I have a positive 2y, would be to take the second equation, multiply it by 2, because that will give us a negative 2y, and then I can add these together. So here I've outlined what I'm doing here. I have 2 times equation 2, that's right here. So there's equation 2, multiplying both sides by 2. And then equation 3 stays the same. So let's go ahead and do the math here. 2 times 2x is going to be 4x. 2 times negative y is going to be negative 2y. 2 times positive z is positive 2z. And 2 times 3 is 6. And equation number 3 stays the same. And now if we add these together, again, notice that the negative 2y and positive 2y cancel out. And we end up with 5x minus z is equal to 2. And now we're going to take these two equations and put them together, and that's going to form a new system. And this, of course, is a 2 by 2 system. So now to solve this system, we can use substitution or we can use elimination. It's up to you, or the addition method, I should say. The addition method is also called the elimination method. So let me go ahead and stick with the addition method. Notice that if we multiply this second equation by 2, that's going to give us a negative 2z here, which will cancel with the positive 2z. So we have 3x plus 2z equals 9. And now we have 10x minus 2z is equal to 4. And if we add these together, we get 13x is equal to 13. Dividing by 13, we end up with x equals 1. Now, once we know x equals 1, we can plug that in here, and we can solve for z. So we have 3 times 1 plus 2 times z is equal to 9. This is going to give us 3 plus 2z equals 9, subtracting 3 from both sides, and then dividing by 2, we end up getting z equals 3. And then we're going to take x equals 1 and z equals 3, and we're going to come back and plug it into any one of the three original equations. So you can plug it into any one of these. I do think the first equation is the simplest. So we have x plus y plus z is equal to 6. We know that x equals 1, right? We already found that down here. So x is replaced with 1. Y we do not know yet. Z we know is 3, right? We have that right here. And so this says y plus 4 equals 6. So of course y must be equal to 2. And our solution is what you see here. X equals 1, y equals 2, and z equals 3. And we typically write that as an ordered triple, x, y, and z. And in this case, it's as easy as 1, 2, 3. So let's go ahead and do another example to make sure we understand what's going on here. Now again, I'm trying to solve this 3x3 system of equations. This one here is actually kind of simple. Look at this. We have equation 1 and equation 2. We have a negative z and a positive z. So if we simply add these two equations together, so equation 1 plus equation 2, let's write down the result. 2x plus 3x is 5x. Y plus 4y is 5y. Negative z and positive z cancel out. And 3 plus 6 is 9. Okay, now I need to eliminate z again, and this time I have to use the third equation. Well, look at the z here. We have a positive 1z. So to eliminate that, we're going to just pair that up with, again, the first equation. And if we add these together, so I'm just taking equation 1 plus equation 3. We don't even have to multiply in this case. We're going to get 2x plus 2x is 4x. Positive y and negative 3y is negative 2y. Negative z and positive z cancel out, and 3 plus 1 is 4. So in this case, we get to a 2x2 system quite easily. Now we just have to solve this 2x2 system. And again, you can use substitution, or you can use elimination or the addition method. I'm going to use the addition method. So to do that, I want you to recognize here that the least common multiple of 5 and 2 is 10. So I'm going to multiply this first equation by 2, which is going to give us 10x plus 10y equals 18. And I'm going to multiply the second equation here by 5. And that's going to give us 20x minus 10y is equal to 20. Adding these together, we get cancellation here. We have 30x is equal to 38. And so x is going to be 38 divided by 30, and that is 19 over 15. Okay, so maybe not the answer we were hoping for, but let's go ahead and solve for y by taking x equals this value, and we'll plug it into this first equation here. So that's going to be 5 times 19 over 15 plus 5y is equal to 9. This is going to be 19 over 3, right? Because these cancel out here. And then plus 5y is equal to 9. And then what I'm going to do here is just multiply both sides by 3. That'll get rid of that fraction. So we have 19 plus 15y is equal to 27. Subtract 19 from both sides. We have 15y is equal to 8. And then, of course, y will be 8 over 15. And then finally, we need to solve for the z variable. And to do that, I will plug it into, doesn't really matter. I'll plug it into the second equation here. So in that second equation, we're going to have 3 times x, which is 19 over 15, plus 4 times y, which is 8 over 15, plus z equals 6. This gives us 19 over 5, right? We get cancellation here. And then we have plus 32 over 15 plus z is equal to 6. And now to solve this, let me just multiply both sides by 15. Get rid of the fractions there. So on this side, we're going to have 3 times 19 is 57, plus 32 plus 15z is equal to 90. So this is 89 plus 15z equals 90. Subtract 89 from both sides, we get 15z is equal to 1. And then finally divide by 15, we get z equals 1 over 15. So the solution is x equals 19 over 15, y equals 8 over 15, and z equals 1 over 15. And for our final example here, we have a 3x3 system, but it's a little bit different. If you look at this system, you'll notice that we have 3 equations, and we also have 3 variables, x, y, and z. But not every variable is in every equation. This actually can be a little bit confusing, but I want you to understand that this actually makes the problem easier, not more difficult, okay? So let's just look at the first equation here and recognize that there is no z in that equation. So because of this fact, what I want to do is I want to get rid of the z in the other 2 equations. So to do this, I'm going to take the second equation, 6y plus z equals 12, and I'm going to multiply both sides by 2. And that's going to give us 12y plus 2z is equal to 24. And then the third equation is x minus 2z is equal to negative 10. And now you can see that if we add these 2 equations together, we're going to get cancellation here. And then what we have left over is 12y plus x, which can be written as x plus 12y, is equal to 14. Now we'll take the first equation, which is x plus 3y is equal to 5, and now I can solve this by using the addition method here. So what I can do, notice we have a 1x and a 1x. I can just multiply the second equation here by negative 1 on both sides, and the first equation stays the same. The second equation becomes negative x minus 3y equals negative 5. If we add these together, the x's cancel out. We get 9y is equal to 9, or y is equal to 1. And if y equals 1, we can plug that in here. And this is going to give us x equals 2. And then once we know x and y, I can come back to find z. Now, notice that if I pick the third equation, for example, I only need x to solve for z there. So let's plug in x equals 2 here. That's going to give us 2 minus 2z is equal to negative 10. Subtracting 2 from both sides, we get negative 2z equals negative 12. And then dividing by negative 2 on both sides, we get z equals 6. And so our solution here is going to be x equals 2, y equals 1, and z equals 6. And that concludes this video lesson.